Yeah, we may be wimpy, but humans rule the world. Yay!
Why do we humans, quote unquote, rule the world? And it's really, from a physics perspective, it's because we can do one of two things. We essentially can predict and or control the future. Now, of course, that's only sometimes. But what do I mean by predicting and controlling the future? From a physics standpoint, what we're really talking about is predicting. So on the predicting side, we're thinking about we can know or we can make a prediction about where something's going to be in the future. That's essentially predicting the future location, which we're going to call position of objects in the universe. Could be the sun, the planets, could be a spacecraft, it could be a car, it could be a person, it could be anything, any object in the universe. We have the ability sometimes to predict the future location. It's as though we can see into the future and make a prediction about where things are going to be. And I'm going to call that, when we talk about predicting future location, I'm going to use the shorthand of predicting motion. An even better thing humans can do sometimes is to actually control the future. And by that I mean we can control the future location of objects. Cars, planes, electrons, spacecraft, footballs, and any other thing. I kept drawing a blank there. But anyway, and we're going to call that controlling motion. So humans, we rule the world because we can do one of two things. Sometimes we can predict the future, predict motion, but even better, sometimes we can control motion. So here I am juggling in slow motion. And the question is, am I predicting motion or controlling motion?
Okay, so I'm
driving
down
down
the
the
street.
street. And when do we predict or control motion in our daily lives?
I'm predicting he's stopping.
We're talking about predicting and controlling motion.
Okay, what am I
controlling?
What am I controlling?
I'm controlling the motion. I'm controlling.
All right.
Anyway,
What am I predicting?
I'm predicting
that guy
is going to.
Whoa!
Here comes a guy.
Hey.
Anyway,
all the time you're
driving,
predicting and
predicting and controlling. I'm controlling the
motion
motion of the car.
At the same time,
I'm making
countless predictions
countless
about
predictions
the
about the
behavior of
behavior of other moving objects,
trying to anticipate
what they're doing.
All right, that's enough of
All
that.
right, that's enough of that. Here I am in the grocery store. What am I predicting? What am I controlling?
Speeding.
Controlling.
Okay,
I gotta make some predictions here. What's gonna happen here?
Okay,
Controlling.
Predicting.
Predicting.
So you can see
that in all aspects of life, even the mundane idea of going shopping in a grocery store, also predicting controlling motion. For example. Oh, good. Controlling. Motion.
Okay, ready to go.
Okay, ready to go. What if you're just sitting in a chair? Are you predicting or controlling motion? Aren't you just sitting in a chair? Okay, so basically, even somewhere in the back of your mind, your body is aware of your position in the chair, and you are constantly adjusting your muscles and shifting in order for you to stay in that chair. And so if you stop thinking about that, way in the back of your brain, if that stops thinking, like when you fall asleep sitting in a chair like that, you are going to start moving and you're going to start falling in that chair, out of that chair. Okay, so this awesome thing that humans do, we say predicting and controlling motion. Don't other animals predict and control motion? I can think of there's two animals there that are both predicting and both controlling motion. So what makes human beings special? Here we can see a dog predicting and controlling motion. What is the dog predicting? What motion is the dog predicting? What motion is the dog controlling? Sorry, dog, you missed. So, yes, human beings, all animals, I don't think plants do it, but all animals, I don't know, ants, I guess, but I mean, certainly dogs and I don't know what that thing was back there, tiger, lions, and animals with horns. Yes, we all predict and control motion. So why are we able to build things like this and dogs can't? Yay! Pretty amazing. Well, there's a reason. It's because humans, I guess you could say because of our big brains, we have learned how to build science models and then to use those science models to do some pretty amazing things. Okay, so we're going to use this term models a lot this year. They must be awesome, but what exactly is a model? Let's look at a model in a more familiar context. Or just let's look at a model in a context in which you're familiar, which is in math class, which I, throughout the year, will call it Mathland. Okay, let's call this thing, okay, I've got this model, and I'm going to call it the area of a circle model. And the cloud there is just because, like, I don't even know what this thing is, but every model, whether it's science or math or business, I think, has an input side and an output side. And I don't mean in the physical sense, but you're going to put something in this model and it's going to spit something out. In this case, what you're going to put in, you're curious about, okay, I want to know how the radius, if I put in radius on the left, I want to know what is the area of that circle with the radius, that I put into the model. So that's how a model would, but what is that going to look like? You do this in math all the time. Well, a model in general is going to look like one of two things. It's not that mysterious. It could be a graph. So this is a little bit hard to see here, but we have a graph of area, circle area versus radius. And so a graph could be a model, because if you went over to the radius, the horizontal axis, and you found the right radius, and then you would go up until you hit the line on the graph, and then you go over and you say, okay, that's the radius. So that would satisfy a model because you input radius and it tells you area. More typically though, it's going to be an equation. So in this case, we have A for area equals pi r squared. Notice that this equation doesn't use y and x. We use variables that are appropriate for our situation. We're talking about area and radius. So we don't use math y and math x in our equations. We use variables that are better aligned with the physical quantities that we are dealing with in this particular scenario. So that's just an example of a model. It's essentially a graph that becomes an equation. All right, let's look at our two models that we're going to be building during the first part of the course. We have our predictive motion model And that's going to be the one that predicts the future location or position of an object. What are we going to put in? Well, what's going to put in is future time t. 30 seconds from now, 3 minutes from now, 3 hours from now. Where will this object be? And what it will spit out will be the future location, which we're going to call position. And it will also essentially could be a graph of what we're going to call position versus time graph, or an equation, which we're going to call, not shockingly, a position equation. So this model, it does only one thing, and it's going to do it very well if we build it appropriately. It's going to take a future time and it's going to spit out future position in the universe. It's not going to tell us the color of this object, what shape it is, how big it is, whether it's hot or cold or anything. It's only going to do one thing, and it's going to do it really well if we build the model appropriately. We're going to put in time and it's going to spit out future position. So this is our predictive motion model. Notice there's no aspect of control. Well, you'll see that in the next slide. All right. At least as good a model for humans. I think controlling is even better than predicting. Wouldn't it be nice to control a hurricane instead of just predicting where it's going to make landfall? Like, wouldn't it be nice if we could control it? Go back out into the ocean and stay away from our country, please. All right, so controlling force model. It's going to have the same setup in general. It's going to have an input side and an output side. Well, in the input side, instead of time, we're going to say, where do we want our object to be? And there is a time, at time t. So I want the car to be in Tacoma at time t. What's going to be the output? It's going to now tell us, hey, what is the required force? You know, force is push or pull. So how hard are you going to have to push on this object, and in what direction, to make your object arrive at the desired location at time t. And it will also essentially could be consisting of graphs and an equation. Okay, so how do we build a science model in general? Well, it's a 3-step process. Oh, and it's also going to end up with a graph and equation. It's a 3-step process. Number one, and the most important thing about modeling in science, is it must be data-driven. You may want the world to work a certain way, but it doesn't. The world, the universe doesn't care what you want. It is what it is, and our job is to figure it out. So your first task is to collect data. Now, what are you going to collect data on? You're going to collect data. I haven't tried writing it. Let's see if I can write real quick here. You're going to collect data on whatever is your input for a particular model. And then you're going to see, is there an actual relationship between the input variable and the output variable? So what you're going to do is you're going to change the input variable, and you're going to observe, typically by measurement, the effect on the output variable. So step number one is to collect data. Essentially, you're going to be doing an experiment. The next step is you're going to graph that data, because graphing is essentially the way we look for patterns. Is there a relationship between, that's the thing, is there a relationship between the input and the output variables? There may not be. For example, is the day of the week, is there a relationship between the day of the week, like Sunday, Monday, Tuesday, and the weather for that day? I don't think there is. We could collect data and say, you know, I don't think there's a real pattern between Sundays and whether it's raining or not. But that's what the graph, so basically we're going to graph the data to see, is there a relationship? And if there is, you're going to develop an equation for it. Now, we haven't talked about this yet. We haven't talked about this yet. In fact, we haven't even talked that much about this yet. But this collecting data part is where we get into this whole idea of sig figs and how do we measure, etc., like that. Okay, so this is a little background because our next step is to look at graphing data. And how do we develop equations from graphs? That is essentially where we're going next.